Hello friends, now we'll understand Newton's law of viscosity. It states that the shear stress is directly proportional to the rate of shear strain or velocity gradient. Mathematically, we can say tau, that is shear stress, is proportional to du by dy. Removing this proportional sign, we'll need to add the proportionality constant. So tau is equal to mu into du by dy, where mu is called as the coefficient of dynamic viscosity and du by dy represents the rate of shear strain or rate of shear deformation or the velocity gradient. What is the importance of Newton's law of viscosity? We generally say that the fluids which follow the Newton's law of viscosity are called as the Newtonian fluids. Now, next is the unit of the viscosity. Now, here we are talking about the dynamic viscosity. So, the unit is tau is equal to mu into du by dy. We'll rewrite this equation for mu. Mu is equal to tau divided by in bracket du by dy. So tau divided by du by dy, where this tau is shear stress. The shear stress is nothing but force upon area. Du by dy is this du is nothing but the change of velocity and dy is change of distance. So force upon area whole divided by velocity is nothing but length upon time and change of distance is 1 upon length. So we are getting force into time divided by length square. The unit of force is Newton, the unit of time is second, and unit of length is meter square. So the SI unit of viscosity is Newton second per meter square. Many of the times we use the unit of dynamic viscosity as poise. So the conversion factor is 1 Newton second per meter square is equal to 10 poise, or 1 poise is equal to 1 divided by 10 Newton second per meter square. The unit of viscosity in CGS system is also called as poise, and which is equal to 1 dyne second per centimeter square. So this was regarding the Newton's law of viscosity. It is a very important law in the fluid mechanics. Now, if you look at the slide closely, there is something written, pitch tar drop experiment. Please Google about this. This is very interesting experiment which is still going on and which is related to the viscosity of the material which is called as a pitch star. Okay. Now we'll go to the numerical on Newton's law of viscosity. The numerical is like this. A plate 0.025 millimeter distant from a fixed plate moves at 60 centimeter per second and requires a force of 2 Newton per unit area. That is 2 Newton per meter square to maintain the speed. Determine the fluid viscosity between the plates. Now we know tau is equal to mu du by dy. So in this numerical, what things are given? There are two plates. One is a stationary plate and other plate is in motion or it is in moving. The distance between these two plates, this distance is 0.025 millimeter. The upper plate is moving with a velocity 60 centimeter per second and the force applied, or we can say stress applied, is tau is equal to 2 Newton per meter square. Now, first we want to find out mu. So, mu is equal to tau into dy divided by d. Tau is already given. There is nothing to worry about tau. Then dy is nothing but the distance between the two plates. It is given 0.025 millimeter. What we'll do, we'll convert it into meters. So 0.025 and conversion between millimeter to meter is 10 raised to power minus 3. Now this du is the velocity of the upper plate minus the velocity of the bottom plate. Now here, which is also called as the change in velocity. So we can say it is equal to u minus the bottom plate is fixed. So the velocity will be equal to 0. So what we need to do, it will be equal to 60 centimeter per second. So I can rewrite it as 0.6 meter per second. We have all the values. So what we'll do, we'll put the values in the relation for viscosity and we will find out the value of viscosity. So mu is equal to 2, that is the shear stress, into dy 0.025 into 10 raised to power minus 3 whole divided by the du value, that is 0.6. What we are getting here, the value of the mu is 8.33 into 10 raised to the power minus 5. What is the unit of the dynamic viscosity? So it is Newton meter. Newton second per meter square. So the unit is Newton second per meter square. As I told you, it is common practice to use the unit of poise. So what I need to do, I need to multiply it by 10. So I'll get the value of dynamic viscosity as 8.33 into 10 raised to power minus 4 points. So this was the numerical. All the things were given, just putting the values, and we were able to solve the numerical. Now we'll go to the another numerical. So here the numerical is a flat plate of area 1.5 into 10 raised to the power 6 meter raised to the meter millimeter square is pulled with a speed of 0.4 meter per second relative to another plate located at a distance of 0.14 millimeter from it. Find the force and power required to maintain this speed if the fluid separating them is having viscosity as 1 pulse. So, like the previous numerical, one plate is there, another plate. So, nothing is given related to the one plate, so we can say it is stationary. Another plate is moving at a speed of 0.4 meter per second. The area of the plate is also given 1.5 into 10 to the power 6 millimeter square. The distance between these two plates is given 0.15 millimeter. If the viscosity is mu is equal to 1 poise, what we need to find out? The force is equal to what? And the power is equal to what? Now, if we look at the numerical closely, so first what we'll do, we'll convert the units. So area is equal to 1.5 into 10 to the power 6. It is given in millimeter square. So millimeter square to meter square is so equal to 1.5 meter square. Now next is the distance is given. Velocity u is in the unit of meter per second. So we can say du is equal to 0.4 meter per second. Then dy is equal to 0.15 millimeter. So we are getting 0.15 into 10 to the power minus 3 meters. Okay, so we have all the values. Now what we'll do, we'll find out the stress. Stress is equal to mu into du by dy. So what we have, okay, the unit of mu is 1 poise. So we need to convert it into our regular unit of Newton. So what we'll do, we'll convert it into, so this is 1 divided by 10. Okay, so 1 divided by 10 into du is 0.4 and dy is 0.15 into 10 to the power minus 3. So the value of stress is 266.6 Newton per meter square. Now, from this stress, we can find out the force. Force is equal to stress into area. Already area is given in the numerical, so 266.66 into area is 1.5. So the force is equal to 400 Newton. Next is power. So power required is equal to force into the displacement or velocity. So 400 into zero point 0.4. So we are getting power as 160 watt. Now this was the numerical on the viscosity law, Newton's law of viscosity, to find out various things like power and the force. Now we'll go to one more numerical, and this numerical is particular related to the Newton's law of viscosity. So now, if the velocity distribution over a plate is given by u is equal to 2 by 3y minus y square, in which u is the velocity in meter per second at a distance y meter above the plate, determine the shear stress at y is equal to 0 and y is equal to 0.15 meter. Take the dynamic viscosity of the fluid as 8.63 poise. So mu is given as 8.63 poise. Okay, so what we'll do, we'll convert it into SI unit. So it will become 0.863 Newton second per meter square. Sorry, Newton second per meter square. This is one thing. Now, the relation for u is given 2 by 3 y minus y square. If you want to apply the Newton's law of viscosity, so I can say tau is equal to mu into du by dy. So for that, I'll need the relation for du by dy. Let us differentiate this relation with respect to y. So du by dy. So uh, 2 by 3y has a derivative of 2 by 3 minus y square as 2y. Now it is asked to find out the shear stress at y is equal to 0 and y is equal to 0.15. So du by dy when y is equal to 0 and du by dy when y is equal to 0.15. Putting the y value as 0, so this becomes 2 by 3. So the value is 0.667. Here the value will be 2 by 3 minus 2 into 0.15. At the end, what we get, it is equal to 0.367. Okay. Now, our next part is very simple. Determine the shear stress. We need to find out the shear stress. Okay. So, tau is equal to mu du by dy. So, we'll find out the shear stress at two different values. So, shear stress when y is equal to 0. So, tau is equal to mu is equal to 0. 0.863, and the value of dy was 0.667. So it becomes 0.5756 Newton per meter square. Next is y is equal to 0.15. So tau is equal to putting the value of mu 0.863 into the value of dy is equal to 0.367. So tau becomes 0.3167 Newton per meter square. So friends, we tried to solve the numerical. We tried to understand the theory which is related to the Newton's law of viscosity. If you have any query, put it in the chat box. If you like the channel, subscribe the channel. Thank you.